My spacebar's broken. It's broken. It didn't work the other like 100 times. It's intermittent then? Just waiting on confirmation from Launceston that they are there at the other end. At some point we're going to literally look at the slides. Just roughly. But, yes. Okay, we've waited for Launceston long enough. I'm sure they're alive and they will let us know on the Discord if they're alive. So let's get started. Okay, so last week we got part of the way through chapter 10. Just enough to be able to talk about personas and scenarios. And so what I did in order to get to those was skip a bunch of slides in the middle. So we're just going to revisit those slides, finish off chapter 10. We're going to look at chapter 11 on prototyping this week. I'm going to show you some examples of some prototypes, which is excellent timing, or deliberate timing if you like, because in this week's tutorials, you're going to start thinking about how you're going to prototype your ideas. But I'll talk a little bit more about that once we actually get up to those slides. Hopefully we will finish chapter 11 today, but we'll see. If we do, then we will be able to jump back to chapter 3. So remember that we had to cut chapter 3 short so that we could get you what you needed for your assignment. So we'll see how that goes. Where we sort of started skipping things in chapter 10 was when we started talking about interviews and focus groups as a means for gathering data for our requirements. So when we're designing systems, we need to be able to try and gather as much data about the environment and the people who are going to be using it. And so we've talked a little bit about ways we could gather this information. We might interview people using and have props with this. But we might also do focus groups with multiple people, and we had a little bit of a discussion about how focus groups can be dominated by individuals, and the fact that this isn't always a bad thing. So people with passionate or important thoughts can sometimes be in focus groups, and yes, they might take time away from other people being able to speak in the focus group. We can get some valuable information about from them that you might not have otherwise gotten. If your focus group just gives some sort of plain advice, then you might end up with just a plain artifact in the end, was what we were trying to say there. I'm sure you guys would word that a lot better if this was an exam question than what I can do on the fly standing in front of you. Other ways that we might gather data for our requirement are questionnaires, and these are usually used in conjunction with other techniques, so you might run a questionnaire or a survey as well as having a focus group. And the important point to notice on this slide is that questionnaires can give us quantitative or qualitative data. So show of hands, who knows what the difference between qualitative and quantitative data is? One hand at the back. A couple of hands here, yeah? Seriously, yeah? No? So yeah, that's good. Anyone want to suggest what the difference between qualitative and quantitative is? Those people who raise their hands. Now that I know that you know the difference, now you've got to tell me.
Is it like something that's measurable versus unmeasurable?
Yeah, something that's measurable with numbers effectively. Anyone else want to? Yes?
Qualitative is about the human behaviors and the emotion,
Mm-hmm.
but quantitative data is about the evidence.
Evidence, yeah. Yeah, yeah. I would agree with some of that. You mentioned that qualitative data might talk about emotions and people's moods. That's somewhat correct in that a lot of the data that we collect about emotions and moods is qualitative because we get people to write down their feelings. But there are quantitative ways of measuring someone's mood as well. Perhaps in that you could say on a scale of 1 to 10, how happy are you? On a scale of 1 to 10, how sad are you? That's still measuring emotions or moods, but in a quantitative way. So it's just what kind of data are we collecting here? But you're right that often when we're asking about feelings or just general feedback, things that maybe are short answer questions from people, we get that in qualitative form. So sometimes that involves getting someone to write a paragraph about what did they think were the best items, best features of an app. And you might just give them a free open answered question here. Or a quantitative version of that might be, did you like the mail sending feature? Did you like the calendar feature? And did you like that on a scale of 0 to 10 or something like that? So once you start to introduce scales and things like that, it becomes quantitative. We can still pull quantitative data from what might seem like qualitative data. We could do word counts over people's things that they write out. So maybe someone writes an essay and we check how many times did they mention the phrase HCI and use that as a way of marking your assignment. It's a quantitative measure, but it's not necessarily a good one because I wouldn't get very good marks if I did a word cloud from your assignments. I should read them and interpret them. And it's that interpretation that is subjective when it comes to qualitative data. But I'm sure you guys have heard all about quantitative and qualitative in other units, so I won't hammer on too much about that. Other things that you might gather data from is existing products. So I think I did mention this last week, but I can't remember, so I'll say it again. That people have expectations of systems when you're making a similar product. So if you're making a product that tries to stop people from sitting down on their chair, so a lot of people's assignments talked about sedentary cushions, you would research what similar products had, what features those might have, because people who have used those cushions or have heard about them before, when they go to consider your product to buy, they'll compare your product to that product. They'll say, well, does yours have the option for different materials on it? Can I get it in different shapes and things like that? Those requirements would come out from that of having different shapes, having different materials is some requirement that you might learn from researching other similar products. You might get that data from doing questionnaires on prospective consumers as well, but you might just get this from researching existing products. When we are gathering this, there's two kinds of observation that we can do here. We can do direct observation or we could do indirect observation. In general, indirect observation is not really used when trying to work out the requirements of an activity. The best form is really direct observation, but we should consider the pros and cons of this, particularly that it requires a time and amount of time and extra commitment from someone on the design team to do direct observation, so literally following around potential users and making notes of what they're doing. Those notes are likely to be more accurate than something through indirect observation. Because details can get lost in indirect observation. So if I wanted to know how often people used a printer in a in a day, for example. I could do this with direct observation by literally following around everyone in the workplace. Maybe I'm sitting next to the printer and writing down on a piece of paper when someone uses that printer. An indirect observation of that might be that I would survey the people and say, how often do you think you use the printer every day in the workplace? And so making that indirect, suddenly we can have inconsistencies in our data. It's not exactly the information, exactly correct information. So you need to consider whether or not you need that information to be perfect or not. Using that example that I just pulled out of the middle of out of thin air, you could also observe that by using system logs in your workplace. So it wasn't a great example, but whatever. Yeah. So indirect is a record of past behaviour, effectively. Another form of data gathering that you could do is by studying documentation. So if you're trying to integrate a system into some greater system, then there's hopefully existing documentation about that system. Or if you're trying to help make a system more efficient by bringing in a computer-based artifact, then you could look at the existing procedures and rules of the workplace, perhaps. If we're looking at a workplace, we might want to know, are there any restrictions on noise requirements? So are we allowed to make an artifact that makes large beeping sounds, or is it literally against the health and safety rules of the organisation, the health and safety rules of the building owner, even? It's kind of dry stuff, so you'd be maybe trawling through stuff that is probably pretty dry, but you can get requirements from studying documentations. Maybe there's some rules or things like that. The important thing to notice, though, is that we shouldn't use this in isolation. So just reading documentation isn't going to give you absolutely all of your requirements because it basically doesn't involve the users. You can't get everything that you need in human-computer action just by reading a book. You need to interact with your potential users and make observations about the way that things work in reality. We all don't follow the rules half the time as well, so just because a rule is written down on paper doesn't necessarily mean that that's how your system might be used in reality. And the only way to work that out is by observing it or surveying your users. So some examples here. This is a cultural probe, and so it's a little bit hard to really tell what's going on in this picture. Yeah, hopefully you can see. What this is a little package that you might give to someone who's going to use your system or going to be a potential user, I should say. And inside this we have some things that they can use to record their thoughts and complete some tasks. So what's not in this image is that you might give them this set of items and then give them some tasks to complete. And that's entirely up to you of what kind of tasks you give them. So in this one, we've given them a little disposable camera so that they can record some pictures. There's probably a diary in here that they can write down on paper some of their thoughts. And we don't have enough context to really know what the tasks are here, but maybe you're giving this particular cultural probe to someone in a museum, and you're saying, okay, go and take pictures of the things that you find the most interesting. Show me pictures of things that you found difficult to navigate in this location. Write down on this map, annotate on this map of the museum places that you went to. And then you get them to hand this package back to you, and you've got a whole heap of ad hoc data here. You've got a bunch of data that is collected in a way that doesn't follow a scientific method of any kind. This uses an artistic method. And so you can gather information from this, probably a lot of qualitative data from this sort of thing. An example I saw, we don't have it here, do we? No. Was that depending on what you want to try and get out of this cultural probe, that would that would change what you would put in this probe and what questions you would ask. So an example that I saw was trying to get little kids to explain the bullying problem in their school. And their cultural probe didn't really lock them into any kind of medium. They could have typed something out, I think, or they could have used some stickers, or they could have used a pen and paper. The pens, the papers, the stickers of little kids, so they were little stickers to represent themselves and their teachers. These were all put in the cultural probe, along with some instructions to say, using these stickers, explain a scenario where you've been bullied or where you've seen bullying. And so, using a little bit of creativity from the participants, the researchers were able to get some slightly more interesting results from the kids, rather than just getting those kids to write down on paper something that they remembered. One, they're kids, so they're not really good at expressing themselves with words. We're talking about really young children. So giving them a way to express themselves in this cultural probe was an interesting way of getting some data back. I don't really know that much about what happened in that, but it's an example that I saw. But again, it's not using a scientific approach, it really is an artistic kind of approach, and so the interpretation of this stuff can be quite subjective. We're not really going to look too much at these images because they don't deserve to be looked at because they're too low resolution. That's what you get, slide makers. So you might, another way of collecting data is by conducting contextual inquiry. So this is a way of studying where the expert is the user and the designer is the apprentice. So usually it takes the form of an interview. This is just one example where maybe it takes place at the user or the expert's workplace. So where they're likely to be using the system. It might take 2 to 3 hours, and it follows these main principles here. That we can understand the context, so that's a fairly important principle when talking about contextual inquiry, is that we look at the context. So when we talk about that, we see the workplace and what happens in it and what interactions take place within that context. The user and the developer form a partnership, and anything that, when we're trying to interpret the results from this, the observations are interpreted by both the user and the developer together. So one reason you might do that is because if you collected all this data from contextual inquiry or some other thing and then took it away and just tried to observe it later on, there might be idiosyncrasies in there or random bits and pieces that you don't fully understand. And so if you interpret this while the expert, the user, is there with you, then you can query them further to say, well, what does this mean? Why was this particular thing happening? And yeah, it provides some focus for the project to see what you need to look for. Just checking if Launceston has had anything to say. Well, they're dead quiet, so it's possible that their recording isn't working. Or Wells. So that was a whole heap of different ways that we might collect data. We saw questionnaires, we saw focus groups, we saw contextual probes, we saw cultural probes, and contextual inquiry. These few slides here have some dot points of things that you might want to consider when doing data gathering, because everything has a caveat in HCI. There's nothing really black and white. We need to consider a fair bit of stuff. There's some stuff here about stakeholders. I'm not going to go into a huge amount of detail about this. Those of you who are doing project or basically any other unit here have probably heard about stakeholders before, so we're not going to try and list a huge bunch of those. Well, we are because it's on the slide. But an interesting point to make here is that when we're talking to our users, we should look for real users, not managers. Does anyone in the audience want to hazard a guess of why this point's here? So this is, before you answer, because I'm sure you're all going to answer really fast, this is an example of taking a look at these slides, seeing a dot point, and then if there was an exam question about things we need to consider, and you just wrote, we need to consider real users and not managers, because you've somehow managed to remember that dot point, you wouldn't get like any marks for that. You need to explain why we might look at real users and not managers. And I only really expect this of things that we have discussed. I'm not expecting you to go fully crazy about dot points that we're glancing over. That would be mean. But you need to try and engage the brain in the exam and try and fully flesh out your answers here. It's possible that you might even get an exam question that says, why do we consider real users instead of managers? And then you go, well, all I've remembered is that dot point, and I don't remember why. So just keep that in your mind, that you need to be actively thinking about these things. Anyway, so that was an aside. Why do you think we might use real users and not managers when we're collecting data? This is not to say we don't talk to managers, but why would we talk to real users over managers? Yes?
Because they're the ones who are actually using the product at the end of the day.
That's right. Yep, pretty straightforward answer. So I don't want to say it, but it's a lot of stuff in this unit and on the exam, and the questions can come down to common sense. It's a pretty common sense answer that if you try and gather data from just the managers and ignore the users, this happens in real life because maybe you've only got a limited amount of time, maybe you've only got access to the manager who wants this system made, and you try and elicit all the requirements just from the manager and not from the people who are using it, then your requirements are not going to be in line with the people who are going to use this system. Managers have different motivations compared to other users. They want efficiency, no doubt. They have a quota to fill, things like that. We're sort of demonising managers here, but they do have different goals as opposed to the people who will ultimately use your system. You've got to think about their goals. You'd still talk to managers though to try and get some overall information of what is appropriate within the workplace, for example. Yeah, there's some other points here about stakeholders. Thought I said I wasn't going to talk about stakeholders, but different stakeholders can have dominance, and this can affect what your requirements are or the outcomes. So when we think about Milo, for example, we've got the stakeholders are the students, the lecturers. They're pretty straightforward because you guys use Milo. I put stuff on Milo for you to use. But there's other people who interact with Milo. There's admin staff who need to make sure that our university student ID system somehow magically works with Milo. I don't know who those people are that manage student records and stuff, but they lost my record for like an entire month, and which meant that my PhD thesis was delayed in being marked. So I just wanted to, vent my anger here. But whoever those people are, they're idiots. I mean, anyway. But those are some people who might be stakeholders. The people who decide ultimately to, when they're deciding are we going to choose Milo or are we going to choose some other alternative, they're considering the budget. So how much does it cost for Milo as opposed to some other learning system. We have our student management admin people as well. No, that's it. So, those people who are making the buying decision, those people ultimately have some dominance in the requirements here that we work out. We have a certain amount of money. So clearly there's some problems with Milo in terms of they've had a lot of constraints. They're trying to make a generic system that works for a lot of universities. And so they maybe didn't fully consider the end users, which is you guys. There are too many other stakeholders here. And so that leads into balancing and functioning usability demands. Some slightly more technical considerations when we're trying to gather information. Who has ownership over the system? How will version control be handled? So will different users have different versions of the artifact at different times, perhaps? Or how will you be able to revert to an older version? Or how do multiple instances with different versions interact with each other, if there is such interaction? How would we handle communication, not only within our own team, but communication with the customer? And these are sort of, again, technical things, but this one's slightly more interesting to say, what about communication between users when designing these systems? So people use different terminology depending on their level of expertise or their domain, their expert domain. So, you know, an example might be you're developing a system for TAS networks, right? People who deliver our electricity. And so when you're documenting all of this or getting information from different stakeholders within that company, you might talk to different people in different areas. So you might talk to engineers who are literally the people getting in the helicopter and you know, hanging out of the helicopter and adjusting the power lines in some dangerous way. That sounds really cool. I want that job. But you might also talk to people who are just in charge of sales and trying to bring in new clients or customers. Or maybe you're literally talking to the end users. You guys use electricity, and maybe we're trying to make a system that teaches you or gives you information about how electricity is made or how much electricity you're using. You guys definitely have different terminology to what the engineers might use, and the salespeople probably have different terminology as well. And so this isn't something you can get around by saying, oh, well, just let's all use exactly the same term. You need to just try and realise that this is something that will come up in your results. You as the designer have to think at a higher level than all of these users effectively. Anything else to say on this one? Yep, okay, so some knowledge within a domain might be distributed amongst all of the stakeholders, for sure. Maybe we all know that electricity has electrons in it. That's some information. But maybe there's some implicit knowledge that we don't know about electricity. And so this sort of stuff can be hard to dig up because experts don't realise that they know some things that other people don't know. They don't know the limits of their knowledge. So how do you articulate this knowledge effectively? And of course, when there's so many stakeholders, trying to get them all in the same room or contact them is difficult as well. So these are some kind of guidelines resulting from these considerations, I guess. We won't go through these in any great detail. They're relatively straightforward, but we should be involving all of the different stakeholders. But this is probably an interesting one that might not be covered when we talk about stakeholders in other units. It might be, it might not be. I don't really do those units. It's not my thing. Is that we should try and involve more than one representative from each stakeholder group. Anyone want to guess why that might be the case? I guess another way of phrasing this question is, what happens if you only get one representative from a stakeholder group? Yep, so it might not be an accurate representation of the group. So that individual, by definition as being an individual, might bring some things that are to the table that are only related to their personal thoughts and not necessarily of the group. It's relatively straightforward. This is not always easy to do, and sometimes you do end up with just one person representing a bunch of stakeholders from their group, but it's something to consider. Use a combination of data gathering techniques. So this is a good idea because if you find out some information from one technique and then find out similar information from another technique, then this can sort of confirm your suspicions because you've used a different way of collecting this information. And throughout this whole process, one thing that we can try and do to try and represent information to stakeholders is by using props. Including prototypes. So we're going to talk about prototyping today, but being able to illustrate your ideas to other people can be difficult with words. I know I can struggle with that sometimes, just babbling on at the front of a lecture, looking at slides that don't have pictures. But when there's a prop, something that I get to hold in my hand, or there's a picture on the slide, then clearly that helps the process. When you're trying to interpret this data, you should try and do this as soon as possible after the data gathering session itself, so that things are fresh in your mind. Try and do a broad interpretation first before diving deeper. And yeah, there's different approaches which emphasize different elements, but we're not really talking about class diagrams, object-oriented systems, and any of this sort of stuff today, or ever in this unit, I don't think. Okay, so this is where we got up to last week, where we skipped all of those slides, so now we've covered them, which is good. And we talked a little bit about scenarios, use cases, as these are one form of prop that you can use when trying to articulate your ideas. So I think even in the assignment spec, where I've now given you a CRA, the little grid, to say what's required for HD level and distinction level, something that distinguishes scenarios that are at a pass level to HD level would be how well it communicates your idea. So you could probably pass this assignment by submitting a scenario that is a scenario, that's fine. But in order for you to get actual good marks, which I'm sure you all want to do, you need to use some techniques that will make this actually illustrate your idea. Because that's the point of them. They're trying to illustrate to other people ways that the system might be used. And so we looked at this, we didn't really look at it, and we're not going to look at it in any huge detail here. Of an example of a scenario, I think I had suggested to have a look at this in your tutorial last week. It's probably a better scenario for reading the scenario. But there were some interesting things here that they included multiple personas here, and one particular thing that came out of this scenario, ignoring a lot of the starting stuff, was that they spent a long time trying to work out what their travel plan was, but some people, when they use these systems, maybe they're doing it late at night after dinner, and they got to a point where they had found some more information, but it was getting late, and these children are quite young, they needed to go to sleep. So they decided to save their settings. I think this is quite an old example, I suspect, because it emails them a summary rather than using any kind of account-based system. But by writing this scenario, we could extract some requirements from this that people won't be able to do all of the things they need with this travel organizer in one go. So there's a requirement that people are able to save their options and continue on, because there's quite a lot of browsing for these people to do when they're looking for going on a sailing trip. That's my summary of that. Went longer than the thing. So scenarios describe how personas can achieve their goals effectively. This is a use case here, and so if we contrast this use case, which I'm sure we do in other units, if we contrast this use case to the scenarios, we can see that it's a lot less personalised, and it's indeed a series of things that might happen, and it's more something that you would give a programmer in order to get them to actually develop this system. It talks a lot about data validity and how these steps might go in order, and then we go even deeper into this in that there might be some alternative courses, again mostly related around data validity again. So contrast these use cases with scenarios that they're much more focused on functionality rather than the interaction specifically. Yeah, again, use cases, so we won't deal with this too much, but what this use case diagram can show is the actors and the different actions that they can take within the system, and so we can see that by the lines indicating which actor is doing which possible use cases here. And so for your assignment 2, the one that you're doing at the moment, I'm not expecting use cases. I'm expecting scenarios. but if it helps you to try and describe your idea or the way that people might use it, you can use use cases in a way, but we're not going to be assessing this as, are you doing use cases exactly right? We're much more caring about scenarios and personas. I think I mentioned last week, this isn't intended to be a mini version of project. Project students, are you doing use cases for your projects? So why we do it here? Hopefully you've already done them or something. It's like semester 2, right? Nearly done. Yeah, some other, talking about essential use cases here of, they're much more abstract, but also from this we can work out what responsibilities the system absolutely has to do, and what some things the users might intend to do. And this is done in an order here that we can see that first they intend to get some visa requirements, and the system is in charge of requesting from the user what their destination is and their nationality is, because that's clearly something that changes what your required visa is. So I'm from Australia and they let me basically in anywhere, but other places you have to pay much more money to get visas. Even for travel, I mean, just for general travel, but you know, visas are tricky. We're not going to talk about task analysis at all. So we're going to skip over these slides because they're at the end. We don't really care about hierarchical task analysis, but we'll just hit the summary of this chapter. Ooh, we got there. So clearly getting requirements right is crucial. So that there is a difference between getting requirements and getting the requirements right. And so there are different kinds of requirements, and each of those is significant in interaction design. There's a fair few different techniques that we've seen here. We've looked at questionnaires, interviews, observation, both indirect and direct, but we've sort of talked about how direct observation is better than indirect. Sounds like an exam question. We've talked a little bit about scenarios as well, and we didn't talk about task analysis. Any questions about any of that before we jump on to chapter 11 for prototyping? I imagine there might be some assignment related questions, although those are sometimes best to send through your tutors, because a lot of these questions vary depending on what your group is and what your group idea is specifically, because we've gone so broad with this assignment. Yay. We'll start on chapter 11 before we take a break. So yeah, we've just talked about getting requirements out of our users and based upon observation. And during this requirements gathering phase, we might want to have some prototyping, prototypes that we can show our users to say, are we getting the requirements right? Is this system that we're planning on making meeting your requirements? And the easiest way to do that is to make something that's low cost and easy to make, because then you can throw that away and you can make multiple ones of them and iterate on them. Rather than going, okay, we've got some requirements, these sound about right, let's build an entire system, then ask the users again, and they say, well, no, none of this is right, throw out the 10,000, 20,000 lines of code you've just written, or more. That was probably lowballing that, actually. So prototyping is important, that's why we're doing it for assignment 2. We're going to cover these things here, particularly prototyping, but then looking at how that relates to conceptual design and concrete design, and actually using scenarios with prototypes. There's a little bit of stuff about actually generating prototypes and how you can construct them. Just checking on Launceston again. Feel like a parent or something. No, still not there. Naughty. So prototyping, we're going to look at what is a prototype. We're going to look at why on earth you might prototype, different kinds of prototyping, and the compromises that you might take. And that's those compromises can be different depending on which approach you take. So you might do vertical prototyping or you'll do horizontal prototyping. And so, yeah, that changes what compromises you make when you're doing this. And then also about how the final product needs to be engineered, I guess. I don't know what on earth this picture is, but it's an example of 3D printing, which is one way that you can prototype things. Are there any like engineering people who understand what on earth that's supposed to be? From my understanding, I think if you turn one gear, absolutely everything else turns. I don't know. I don't even see how it's relevant, so whatever. In other design fields, though, we might prototype things as a small-scale model. So, yeah, using 3D printing, we might make a miniature version of a car rather than making an entire car to show to people. There's clearly quite a difference between 3D printing a little car model or even just showing it on a computer compared to making an actual car. But again, there is still a difference between that physical miniature model of a car and a 3D model of it on a computer, because it's tangible. It's something that you can hold in your hands, you can see it from all angles. You could maybe put it next to some other 3D printed cars in a miniature environment. Yep. 3D printing, but yeah. Is that 3D printing actually like doing it's like knitting it or something? I don't know, it's weird. No idea, sorry. Anyway, so what is an example of a prototype? This could be quite a lot of things, and it's not just restricted to what's here on this slide. It might be that you're doing a series of screen sketches, so on a piece of paper, each piece of paper is a different screen. It might be a storyboard, which is slightly different to a series of sketches in that it might show actors doing things, so actors interacting with the artifact. It might be a PowerPoint slideshow that highlights the features, or more accurately for this unit, a PowerPoint slideshow that emulates an actual screen interface, something that you can click on the buttons and it will take you to different screens without actually having to function entirely. It might be a video pretending that the system's working. It could be a lump of wood. There's an example in the other slides that I'm going to show. Yes, Kit 305 students, I'm going to show the lump of wood picture from the other presentation later on. It might be a mock-up made of cardboard, or it could be a piece of software with limited functionality. And that software could be written in the language that you intend to make the final product in. So if you're making an Android app, you could prototype that app in Android Studio, and it's still written in that language, but it doesn't do everything. It just shows the screens or makes other compromises. Or if you're making still an Android app, you could develop it in something like Balsamiq, which doesn't use a language, but it's a piece of software that has limited functionality because it's faster and cheaper to make it that way. Which is a bit of a spoiler alert for this slide, I guess, of why on earth we might prototype. In chapter 10, we talked about gathering data, and that was mostly from trying to gather requirements. But also, you're going to want to gather data in terms of, are we getting those requirements right? So we want users to be able to evaluate our work. We want users to be able to give us feedback. And so if we do that with a prototype, they can see, hold, and interact with the prototype much easier than they can with a document or a drawing. It's tangible, possibly. It's a lot easier than, so see, holding, and interacting might be, that car example where we look at a 3D model of a car versus a 3D printed one, whereas just reading a document that has dot points to say what are the features of a mobile app compared to something made in PowerPoint or Balsamiq, that thing in PowerPoint is going to be a lot easier for the person to understand, and it gives you more things that you can evaluate. You can evaluate, do people understand the layout of the of the screen, how long does it take people to complete different tasks with this prototype. It allows you to all, as a team, communicate effectively using this, and you can test out ideas for yourself as well. It encourages reflection, and prototypes can answer questions from stakeholders that they might not have even known to ask if they were reading a document. So an example that was given last year, it's a bit of a weird trivial example, is that maybe you've got a heavy digital camera, one of those digital SLRs, quite large, and you're prototyping the idea of giving that camera a handle so that you can carry it easier. And so rather than going out and trying to make that out of the final materials and getting it perfectly right, so moulding it to the hand, you might just make some really trivial handle for that and super glue it on, maybe. So I'm trying to make this low cost, this idea. And then you could give that to people, right? So you give this camera that has an extra special handle on it. You can give it to stakeholders, and then maybe one of those stakeholders is using that camera. They go, oh, this is pretty cool. But then another stakeholder goes, okay, well, what if I want to put this into my backpack? It doesn't fit in my backpack anymore because you put these stupid handles on it. And you've only just realised that because you realise that through prototyping it and using that with a user who has certain requirements for this particular random idea. And so by that point you go, okay, well maybe this wasn't a good idea, or maybe we need to make the handles removable. And you haven't lost much money because you just used some super glue and some plastic to prototype your handle. Of course, the compromises that you make when making that handle might be that the super glue isn't strong enough for your super heavy camera, and so that's not representative of the final product, that you can't shake it, where you could shake it but then the camera falls off. But the final product might be a lot more stable than that. That's something that the prototype would have a compromise in when you make it. Does that make sense to people? That, you know, as a random trivial example? Making the decision over whether or not you like those handles on the digital camera is a lot easier to make for people compared to reading some dot points or a picture of that on paper. So someone goes, they read the piece of paper that says the handle is attached to the left and right of the camera and are made of marble, some material. And you go, oh, I don't know. I don't know whether I like this idea or not, but if you see the prototype, then it might answer some questions that you didn't even know to ask by reading that piece of paper. Like, can it go in my bag? Although maybe some sane person might actually ask, it's bigger, does it fit in the bag that I usually use? But it's a trivial example. We're skipping over these two slides. Walls of text, they don't deserve to be talked about. So we talked about what is a prototype, why might we prototype. Let's talk about what things you might actually prototype. So what are the things that you're trying to prototype? So you might prototype technical issues, but more likely you would prototype the workflow of how people will use the system. What's an example? Yeah, task design. So showing that a prototype can complete a task without it actually completing the task. So maybe some kind of word processor you're trying to prototype, and you need to make sure that people can place images wherever they want on the screen. That's the thing that you want to make sure, that the way that people choose their image and the way that they drag their image onto the screen, or the way that they, well, there we go, I've already assumed how someone might interact with this system. It might be that we say, how do people choose what the image is, where they're going to place it, can they manipulate it later? But we wouldn't prototype, can we save that? Because that would be a waste of our time to work out how are we going to save all these images, and working out the technical difficulties of serializing the file and making sure that it doesn't get too big and making sure it can be read in other versions, blah, 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 technical stuff. No one cares about that when you're just trying to test out how someone might complete the task of moving around a bunch of images on the screen. And so that sort of harks back to the fact that our assignment 2 is not about functionality, it's about how people use the system. So you don't need to make it save, you don't need to make it actually interact on a network with other devices for your prototype, unless that was your absolute focus, and it's not really the focus for this unit of making that stuff work. Yeah, you might prototype screen layouts because you might want to try out different layouts, difficult, controversial or critical areas. And you'd show alternatives of this. Yep, we'll do this slide and then take a break. So in terms of prototyping, there's different kinds of prototypes, of course, and one way of categorizing them is their fidelity, so what sort of quality they are and how many compromises do you make. So low fidelity prototypes, those often use a medium which isn't like the final medium. So if you're trying to prototype a mobile app, drawing it on paper is clearly a different medium to the final medium. The medium that you would choose for this is usually quick, cheap and easily changeable things. So examples of this are sketches of screens, task sequences, post-it notes and moving them around, and storyboards. The last point, Wizard of Oz, I'll explain in a second. But also I believe that low fidelity prototypes could include things that, include a PowerPoint presentation that show all the screens of an app. That's a different medium to the final Android app that you're making. And it's still cheaper and quicker to work with, and it's easy to change. So lo-fi prototype doesn't immediately equal something on paper or something that's glued together or sticky taped together. It just means something that's cheaper and further away from what the final product might look like. So what we have here is this last point for Wizard of Oz prototyping is where the prototype, we pretend that it has functionality that it doesn't have. So an example of this might be that you've got a system that is supposed to use speech recognition as its primary interface type, and so you get your end user to say something out loud, so they say open file, they literally say that, and then on this lo-fi prototype somehow on the screen the words open file appear. You can get this in a lo-fi prototype by having someone behind the curtain listening and typing in what they've just heard on the screen. So they've got a keyboard behind the curtain that's connected up to the computer, giving the impression that the speech recognition works, and that's cheap as free compared to getting proper speech recognition. I know that you can get speech recognition packages and things like that, but having someone behind a curtain with a computer keyboard plugged in is even cheaper than a free plug-in because it costs you very little to accomplish this. And so the reason why it's called Wizard of Oz, for those of you who are not fully aware of how that movie goes, I was one of these people. I'm a little bit embarrassed. I might be the... Who's seen Wizard of Oz? Okay. I didn't really understand why it was that. I was like, we're going to follow the wizard? I don't understand. It's more to do with the scene where the wizard is found to be pulling all the strings almost literally behind the curtain later on. And so it's before the break, for those of you who don't fully understand. Because of myself. I remember how to do this. No, I don't. Oh, yeah. I used recall rather than recognition to understand how on earth that works. I have to recall how this system works. Okay.
The wrath of the great and powerful Oz. I said come back tomorrow.
If you are really great and powerful, you'll keep your promises.
Do you presume to criticize the great Oz? You ungrateful creatures think yourselves lucky that I'm giving you audience tomorrow instead of 20 years from now. Oh, the great Oz has spoken. Oh, pay no attention to that man behind the curtain. The great Oz has spoken.
Who are you?
Oh, I am the great and powerful Wizard of Oz.
You are? I don't believe you.
No, I'm afraid it's true. There's no other wizard except me. You humbug! Yes, it's exactly so. I'm a humbug.
Oh, you're a very bad man.
You'd hope that your participants wouldn't say you're a very bad man when they find this out. An interesting point to note with Wizard of Oz stuff, it's break time, but something to point out is that you can deceive your participants by not letting them know that there is someone behind the curtain pulling the strings and making the prototype work, or you can choose to let them know, and that might just change their perception of it. You don't have to deceive your participants, but if you do, then you start to run into ethical issues with your when you're doing actual research. But you know, it's a choice. So it's not. There's different ways of doing this. It's break time. We'll take 10 minutes. Maybe 10 minutes minus 1 minute because we spent 1 minute watching Wizard of Oz. You know you want to watch this one.
It's the super duper cut.
What's up, everyone, and welcome back to Top 5 Central. Today we're going to be looking at
Yeah, no, I'm not doing that. It's annoying. That is. Okay. It's a little weird. One more minute of break. A single crumb can bring down a MacBook Pro's keyboard. It's a big thing, you should Google it. One of the features of the 2018 MacBook is that it's crumb resistant. Although they don't like to admit that. But that's like the biggest thing that they changed about the keyboard. And, you know, that's my O key, which I swapped out because it was broken. And then that's my L key, which I swapped out because that was broken as well. But I can't swap out my spacebar. Get the uni to buy me a new one, or it's under warranty, but I don't have 2 weeks to spend while they go away and fix it. There was a big debacle trying to get compressed air, and that worked for a day, even though it took me 3 days to find compressed air. Yep, Kingston Big W, in the end, had 1 bottle left. Yeah, there's something strange going on where people are buying it all up according to the guy at Harvey Norman. I don't know why. I'm sure it's a drug-related thing.
Yeah.
It's what it feels like, especially given it's Tasmania, but anyway. Our air quality is like 2 out of 100. We're awesome. Or is it 8? I forget. Anyway. Alrighty, break's over. So. If I could get everyone's attention. There we go. That's better. So we'll continue on with chapter 10. No, chapter 11. Well, that was weird. I started talking and you guys all got louder. Hello. Yeah? Good. Being up the back portion doesn't mean that we can't hear you. It means we can hear you even more in the back of our heads. These guys, anyway. I can hear you in the front of my heads. Don't like it. Okay, so we talked a little bit about low fidelity prototyping and some examples of that, including our wonderful Wizard of Oz behind the screens. Each one of these slides talks about these points a little bit. Storyboards, we'll talk about them a little bit because they can be used in conjunction with scenarios where they bring in more detail and show the state of the system or the artifact as we progress through the scenario. And allow us to have a bit of a chance to role play. We're already doing that with scenarios, but storyboards allow us to illustrate this, literally illustrate it. So it's a series of sketches that show how a user might progress through the system or progress through a particular task. So you try and constrain this to a particular task the user might be doing in the system. And it's used early on in design. This is not an example storyboard. This is a table with advantages and disadvantages about lo-fi and hi-fi prototypes. This is, so this is, I suppose, an example of a storyboard. And the point to be made about this slide here, and a lot of you come to me even in assignment 1 saying, oh, I can't draw for can't work out another way to finish that sentence. I can't draw very well, and so it doesn't matter. It's not about drawing ability. If you do worry about that, maybe practice being able to draw simple symbols, but really most people should be able to draw a stick man, really. But if you can't, then you don't have to draw something on paper. You can produce it using software, as long as it communicates your idea. You might do card-based prototypes. So this is quite a specific form of prototyping that people conduct. You could use index cards of roughly 3 by 5 inches, and each card might represent one screen or part of a screen, and you can switch out the cards when evaluating these things. So something to think about when you choose how you're going to prototype things. We're looking at physical examples at the moment. But think about this for if you're going to do a software prototype, which most of you probably will. Think about how people might how you will be able to evaluate people using this prototype and what would be required. So I get you to think about that in the tutorial this week. If you're doing card-based prototypes here and someone was using this system, how do we... There's no fake button for getting to the next screen here, but you can imagine that they'd fill in this form and press go. It would take them to the next screen. Clearly, if this is a piece of paper, then they can't click go, but you would get your participant, your tester, to indicate that they're pressing the go button, and then you would physically switch out the index card with the next screen for them. So you perform the navigation for them with this lo-fi prototype. Apparently this is often used in website development. We've already talked about this Wizard of Oz prototyping, and this is, so the example was because I'd read it on the slide, I think, of someone maybe saying something out loud, and you get your person behind the curtain in another room, connected to the same computer, effectively doing maybe navigation or something more complicated like speech recognition for you. So they're switching out the slides to the right location. And whether or not you choose to tell them that there's someone behind the curtain is up to you. Hi-fi prototyping. So these use materials that are much more what you would expect from the final product. They look a lot more like the final system than a lo-fi one would. We can develop hi-fi prototypes by integrating existing hardware and software components. There's a danger here that users think they have a complete system, and we'll talk about what compromises we do make. So what they mean by that, by saying see compromises, we'll look at those slides, but we're not making a complete system here, otherwise it wouldn't be a prototype anymore. There's things that are going to be missing, the system is not complete, so what's the danger that the end user thinks this is a complete system? What things could happen? Why is this a danger? Yep, that's right. So they might get a poor impression of the system if they try and use a part of the system and then realize it doesn't work. Maybe they think that, oh, is this what they're going to give us for the final version? Something where the add to cart button doesn't work. What's another sort of danger from this?
Another one is if there's any big issues, it's harder to change things if you've already put a lot of time in.
Yeah, that's right. So from the audience, that was that a danger of hi-fi prototypes in general is that if something's noticed to be wrong and you've developed it quite a long way in this hi-fi approach, then it can be quite difficult or time-consuming to change that thing. That's not specifically a danger of the users thinking it's a complete system, but it's certainly a problem with hi-fi prototypes. There's quite a few of those, and we'll talk a little bit more about the advantages and disadvantages later. Any other thoughts on this particular point?
Maybe the system just partially satisfies the user's needs.
Mm-hmm.
So, and once they produce a product, maybe that is really far beyond the user satisfaction.
Yep, so the level of satisfaction that they get from the system is lower from this than maybe the final version. Yep, that's right. Other things, I guess, are that maybe it makes unrealistic expectations from the users. So perhaps they see the pie-in-the-sky version of your system that sort of makes it really easy to click one button and find the perfect route to the airport because you've got some kind of travel manager application and you've abstracted away the task of finding transport to the airport with a single button in your prototype because it's not the focus of the prototype. And then the end users get an expectation of, wow, they're going to have this awesome algorithm that perfectly finds me the transport that I need. And then in the end, when you actually go to implement it, you find it's not, well, you knew as the designer that it's not that easy to work that out. There's lots of different variables and it's not a one-button solution. So you can create unrealistic expectations. Another thing that might happen is that people might pick on specific things. People are more likely to pick on specific problems in your prototype because they think, oh, this is so complete. Most of the things here are really well done. And then the only feedback you get from the users is, everything was really great except the add to cart button doesn't work. And you go, well, I knew that. I made it not work. So we're not focusing on that part. And so the user thinks that maybe they've been useful, that they've spotted this problem and that they've given some feedback and they've gone, oh, okay, I've given one or two pieces of feedback that the add to cart button doesn't work and the algorithm for shipping doesn't work, whatever, that's enough, and didn't give you any feedback on the stuff that you did actually want feedback on. So that's something that could happen if they think that they have a complete system. And this comes about because we make compromises when we're prototyping. The level to which we make compromises depends on whether or not we're doing a hi-fi or lo-fi prototype, but they all involve some kind of compromise. Yeah. So for software-based prototyping, maybe there's slower responses than normal, or maybe the icons are not final. Maybe they're things that you downloaded off the internet. Maybe they're things that you wrote on a piece of paper and scanned. Or you just entirely limited the functionality. So if we were making that system for a word processor and we only wanted to make sure that people could place images on their screen, so maybe it's a scrapbooking word processor, and there's no functionality for saving, then that's a compromise that you're making because you don't need to implement that. The ways in which we make these compromises over the whole system, though, can be referred to in two general ways, of horizontal and vertical. So if you've heard of a vertical slice before, and hopefully you're all nodding because I have mentioned it in a previous lecture, you've probably also heard of it before now, is where we provide a lot of detail, but only for a few specific functions, whereas in a horizontal one we provide a wide range of functions, but each one has a lower level of detail. So if you think about slicing up a cake, a vertical slice through it, you can see all the layers of the cake, whereas if you do a horizontal slice through it, you might only get the top layer of the cake, the sprinkles. You won't get to see the jam and the base of how it all works. Or to use an actual software-based example, probably be useful. A vertical slice of a shopping website, maybe you don't really worry about implementing the recommendation system of saying, okay, people who bought this product like this other product. Maybe the thing that you did prototype in a vertical fashion is that you made the add to cart functionality work, the entire checkout functionality work. So not just that when you click on add to cart it shows you the next page, but you can go add to cart and you can press checkout, and that you can enter in your shipping details, you can calculate the shipping amount, and you can press the buy button. All the stages of that work, but you didn't focus at all on making the recommendation system work. You didn't make it so you can have multiple images for each item in the shop or something like that. You shouldn't ignore these compromises. Ultimately, these things will need engineering in the end. So we're going to sort of brush over hopefully the second half of this chapter 11, now that we've talked about prototyping. But we're going to have a bit of a look at conceptual design and concrete design. So conceptual design refers to things like metaphor, or other things that you've used to come up with a conceptual model of how your entire system works. It's an outline of what people can do with the product, what concepts are needed for those users to understand how to use it. There's a mood board here that we're talking about, but there's an example of that later on in the slides. And when coming up with this conceptual design, we might want to prototype different alternatives. So when we're talking about conceptual design, we try to describe our product not about its functionalities, but rather talk about what the project aims to accomplish. So what are the goals of the users, or at least the goal of the product, and how are we going to accomplish that? So thinking about our assignment 2 and our theme of getting moving at work, we might think about, is your product specifically meant to try and motivate people, to try and get them to get up and walk? Or is the goal or the aim of the project to help people who are already exercising at work? Or is it to reward people when they exercise? Is it to make exercise easier? Is it to make exercise more fun? All of those things that I'm talking about there are conceptual rather than the requirement that, or the functionality of it. Those are conceptual things rather than functionalities specifically. So in all of those sentences that I said there that capture roughly what a product might do, you talk about what your actual product does to accomplish that. I didn't provide any functionality in any of those sentences. So it's just a higher level way of describing the product without specifying any specific functionalities. So we've talked a little bit about metaphors already, and so we saw that interface metaphors combine our familiar knowledge with new knowledge in a way that will help us understand the product. Remember the metaphor that we use a lot on our day-to-day lives is the desktop metaphor. So it took the idea of us having things on our desktops and moving them around. That's where our files are, and we literally have a desktop on our computer. So the software version of that uses a metaphor to accomplish that. We need to try and evaluate our metaphors that we choose to use. So does it provide structure? Is it actually relevant at all? So I guess when we talk about the desktop, it's pretty relevant because what we're trying to do with our computers is manage and manipulate a large number of files. And so the metaphor of being able to organize our desktops is reasonably relevant, I guess. Is it easy to represent? Well, yeah, it seems to be. Will the audience understand it, and how extensible is it? But also something that isn't a point on here is think about when the metaphor breaks down. So who remembers the example with desktops of where the metaphor of a desktop breaks down? Yes? Yes! That's right. Well, that was faster than normally I get from the audience. So yeah, I was going to take a breath while I waited for people to respond. Yeah, that's right. So the metaphor of the desktop breaks down. When we think about the recycling bin, we don't normally have our giant recycling bin sitting up on our desktop. But it doesn't really hinder the experience for us too much, and it provides functionality for us. When you're coming up with your metaphor, so yep, will the audience understand it? That is a point there. We should consider whether or not the metaphor applies to our target audience. It might not always be the case. An example of this is that you may be tempted to use metaphor even from other software like Facebook. So if we were making an app to try and showcase art in an art gallery, and we wanted to use the metaphor of a Facebook wall and all the posts that go on there, and you just scroll through them and they never end, you know, or some other thing stolen from Facebook, and then you think about your audience, and then you use a bunch of iconography from Facebook and a whole heap of terminology from Facebook, like being able to like and comment on things, whatever, and then you give your audience to people who are used to using WeChat instead of Facebook, because that's their chosen social networking platform. And I don't know the specific differences between WeChat and Facebook that much, even though I use both. I don't use WeChat for any of the post things, I just use it for communication. But maybe you'll find that if you gave it to an audience who doesn't use Facebook all the time, then the metaphor starts to break down and it doesn't actually serve its purpose anymore. So just think about whether or not your audience is used to this metaphor or not when you use it. So remembering our interaction types of instructing, conversation, manipulation and exploring. Think about these when considering your conceptual model. There they are. I was reading them off my notes, but they're on the slide. It's an insight into my brain that I don't really bother looking at what's on the slides that much. They're there as a tool. And then the interface types that provide interface for the insight for these. So maybe a tangible interface is suitable for manipulation. So sometimes our interaction type can help us decide what our interface type is, but these are not mirrored one-to-one or anything like that. We remember from last week that just because we're using a conversing interaction type doesn't mean that we suddenly have to be using speech recognition or something like that. And likewise, speech recognition as an interface type doesn't mean that we're using a conversational interaction type. Anything to say here? Yep. So once you've got that initial conceptual model of what the aims of the product are and what sort of interaction types will support this, you need to then start thinking about your functionality. So a lot of people go, oh, it needs to have all these functions first, and then try and wrap some conceptual model around it. And I'm sure you're probably all doing that for your assignment, but try and get out of that habit. Try and think about things at a conceptual level first, and then let the functionalities come through later, because it's these conceptual levels that we're going to be doing a fair bit of assessment on, not about how many functions have you thought of. So you need to think about what functions the product might perform, how are the functions related to each other, and what information is needed to actually accomplish these functions. So information, data, whatever. Maybe we need to have a certain piece of data in order to accomplish a task. So maybe there's a task where that we work out what the shortest route to the airport is. What kind of data do we need for that? We need to know what time the user's leaving, or what time they need to arrive there by, is probably the way you do those. What sort of transport would they prefer? What are the bus routes, for example, or what are the available taxi services like Uber and that sort of thing. So there's data that comes from the user and data that you can scrape from online. There's quite a large amount of data for pretty complicated example task I gave there. But even simpler tasks might require some kind of extra information. So transitioning then from conceptual design into more concrete design is what you start to do with your prototypes. So there's a fair few aspects to concrete design, such as choice of colour, choice of icons, remembering the difference between recognition and recall. The buttons that you might need to use the interaction devices. When thinking about this, we need to consider the suitability for our users' characteristics. So a good thing we've already listed these in a persona or a series of personas. Again, there's that accessibility word that pops up on these slides and then we never actually talk about it. But also maybe there are cultural guidelines to follow as well. But not much worth saying there because we're flying through these. So these scenarios that hopefully you've started writing for your assignment, these are used throughout the design process in various ways. They can be used as, yes, an overall basis for the design. So when you think about them, you can elicit requirements from them or think about ways that people will use it. But another way that you can use these scenarios, and I'm thinking about this for assignment 3, maybe in some way, is that you can use a scenario as a basis for a script for user evaluation of prototypes. So we're not talking about evaluation at all today with our prototypes. We'll get to that later in semester, probably when I come back from America and when you guys come back from your break. But again, it's that we have these prototypes and we want to evaluate how usable they are. And so when doing that, we might give people tasks to do. Those tasks could be defined by thinking about your scenarios that you've written. So it's not just wasted work that you write these scenarios at the start and then you never use them again. They might be used as the basis for a task that you get people to do. They're concrete examples of how people use the system and as a means of cooperation across professional boundaries as well. So being able to express how the system is used to other people in the team and other stakeholders. You might have plus and minus scenarios. I don't know exactly what they're referring to there. It's probably something quite specific, but I imagine they're extreme cases of you could have a scenario that's slightly unrealistic that shows an ideal usage of the system, or a scenario where someone really struggles to use the system. And so one thing that you might do is generate a storyboard from your scenario. And so here are some components that you might put together in a storyboard. So representing actions of giving and receiving or transferring. You might represent emotions or reactions. You might represent when the artifact makes a sound or shines some light, so maybe part of it responds or provides feedback. Representing the actual digital devices, but most importantly, representing the actors, the people. I don't know if they're trying to illustrate something here by having a blob man as opposed to a stick man, but maybe they're also just showing that the representation doesn't matter. You don't have to be skilled at sketching here. Yep, so you might generate these card-based prototypes from a use case. So before, when I talked about card-based prototypes, I mentioned that you might choose what the next card is to show, depending on what they've pretended to click on. But maybe in a use case where we're trying to describe a specific sequence of actions where there's no real linear, where it's mainly linear, you could make a card-based prototype where the person themselves just switches to the next card, and it's a fixed sequence. In this one, maybe you do follow the lines here. So using these personas and prototypes is a good way to model the user experience, but also we could try and produce design maps, experience maps, or things like that. The reason I'm not talking about these at length is because we're not going to get you to do these, but it's good to know that these exist. So here's an example of an experience map throughout a particular user's interaction with booking a flight to New York City. Notice that they're using the persona here of Richard that they've come up with previously. He's a tall, senior executive travelling as part of work. I nearly read that as a tall, senior, just senior person, but there's a bit of a difference there. They're a senior executive, not an old person. And we can see on this wheel what their mood is at various points in the experience overall. So how is their mood changing? And there's various actions that they will perform. Some things require extra information to deliver that part of the experience. So passport checks needs some additional information. Contacting the immigration department to make sure that this passport isn't flagged perhaps as someone who's a terrorist. Information of what seat they prefer, and for this particular persona I think it's important to note that they're tall, so they might have chosen a seat in an emergency exit row. This little icon here is describing a make or break moment. So there's decisions to be made at this part that make sure that if we get them wrong, then it might destroy the entire user experience, so these need to be considered extra carefully. And it's specific for this persona that is a tall person, so maybe seating's important. People hate being stuck in immigration, so that's another make or break moment for this one as well. With all of these, it's worth taking a look at the sources that are on the slide to learn a little bit more beyond my description of what's going on the diagram, so I encourage you to do that. This is another way of representing the user experience as it goes on, so an experience map. We show specific steps. In this case, it's for Megan trying to deliver a presentation, and I think they're video conferencing with someone called Ivan specifically. So there's some context that we're missing from these. Clearly, we need a little bit of extra context around these diagrams for us to understand what's going on. But we might need to ask questions about certain steps in the process, make comments, or maybe we will take a look at a step in the experience and come up with an idea. And these would then get fed back into the design of the system that maybe there's functionality that we add for the presenter showing that Ivan is already there, letting them know how many audience people are watching. I would like some of those functionalities to know that Launceston's alive on the other end. They did tell me that they're alive. I will just check that if they've said anything. Nope. Yeah, we're going to flick through these slides about physical construction of prototypes. So something that I've been asked a fair bit, and the tutors have been asked a fair bit, of whether or not you're expected to make physical prototypes for your assignment 2. You're certainly not expected to create them. You can create a simple physical prototype if you like. The level of detail that you go to is going to be quite tricky for a lot of you to try and produce a physical prototype. So examples on this slide are saying things like using Arduino or maybe a Raspberry Pi or something like that, which is things like this, the Arduino board. We clearly don't expect you to be able to create a physical prototype that has an Arduino kit in it and some kind of functionality programmed into this at all. It's more that if you feel the need to represent your overall physical artifact in some way, and you think that's useful to communicate your idea, then you can produce that. But we're caring more about the interaction with that object. And as best you can, you're going to have to describe it all in a document anyway. You're going to have to probably supplement your physical artifact, if you choose to make one, with still some PowerPoint slides showing how the artifact changes based upon interaction. So even if we were making something like a tape recorder as our artifact, and it's got some buttons on it, yeah, you could prototype me a little box that shows the size of the tape recorder, and it's got drawings of where the play button is, the pause button, and the record button. But you wouldn't be expected to make those buttons function using a chipset like this. Instead, you could prototype that entire thing in PowerPoint, where you show a picture of that tape recorder, and I can click on the buttons for play, and it allows us to maybe see what happens when I press pause when we're already playing, what happens when I press pause when it's not playing. Does it just, does it give some feedback, or does it ignore me? How do I record? Things like that. You could represent this entirely on PowerPoint slides. So we're not expecting you to go into the level of detail of this. This one's an interesting one, the Marky, I assume it's pronounced that way, who knows, kit. What this ultimately does is you can hook up any kind of electronics to these, and these map to the arrow keys on your keyboard and the spacebar and the mouse click on your computer. Yep. Old people can use it. And I'll show a better example of the Marky thing in a second. But the last slide here to talk about is that we just saw some physical examples, but also maybe you can construct your prototypes using software. So SDKs, it can go as far as fully using an IDE like Android Studio or Xcode. And some of these things produce a lot of code for you. So it's entirely fine for you to use these things to drag and drop things around, press buttons that generate tens of thousands of lines of code and submit that as your assignment, because I'm not going to mark you on how many lines of code you wrote or the quality of your code. I'm going to mark you on your interface choices, your interaction design choices. And so the way that you construct these, this is the same level of how irrelevant it is of what choice of glue you used for your physical prototype. I don't care what kind of glue you used for it, as long as you can illustrate your idea to me. The IDE and the code that you've used is the equivalent of the glue. I don't care. I'm not going to look at it. Well, I will look at it to see if you've stolen the code from someone and not referenced it. Definitely going to do that. So some quick summary here of prototypes. They are useful for, different kinds of prototyping are useful at different stages. They can answer questions that we might not have originally had from just reading documentation, for example. There's compromises we make, and these compromises need to be considered in terms of the final product. There's two aspects to the design, the conceptual phase that you might want to prototype and the concrete phase that you might want to prototype. There's some things we've seen here. We've seen storyboards, card-based things, physical and SDK-based construction. So I'll really quickly show an an example of that marky thing just because it's cool, but I won't spend too long on it because I do want to show you some other things. So those wires that you would connect to your marky board can connect to anything you want. Usually it's other pieces of electrical equipment, but you can connect them to things like fruit. And there was a little expo down here in Hobart probably a couple of years ago where you could play games by touching an orange. So we can see that they're all connected here. So this would be, you know, left, right, up and down possibly, although that one looks like it's the space key. And so any game that expects input in the form of space and clicking and arrow keys, these just get mapped straight to it. Yep, there was an actual example of someone playing the game with this, but feel free to have a look at that. Yep, so we'll spend just a quick second looking at this example of a physical prototype. So this prototype, these are all on Milo, as you can see, so you can see this. This is a prototype that was submitted last semester for Kit 305 mobile development, which I taught. And so they were given the task of making a prototype, extremely similar assignment to what you guys have got. And for their lo-fi prototype, although I consider this a step above lo-fi because there's quite a lot of good work put into this, it's high quality, they chose to make a physical prototype. And so this was a little book, a little diary. The first page had the overall phone cut out on it, and then you could flip in and out pages somehow. It was awesome. You could slide them in and it would change what the current screen is. I believe this little keyboard here was actually a separate piece of cardboard that they could remove depending on if you were pretending to be inside a text field. So this did require the student, when they were evaluating it with other students and with me, to flick in and out the pages. They had to navigate. They had some little useful steps to help themselves to know this was page 1 so they didn't get lost. This doesn't help me as the user, but it helps the person be the wizard effectively. And the other thing I want to show you is an example of a PowerPoint prototype. So I showed this in the mobile unit last semester. I've actually provided this one now on Milo for you to use. I've heavily removed a bunch of the identifying information, I think, pretty sure. And so you can see some of the things that they've done. We can see that it's still just a regular PowerPoint presentation, but each slide represents a screen, or it might represent variations on a screen. And the way that we traverse through this PowerPoint is not linear. So it's not that I would just sit here and click, click, click and see each screen in this very linear order. It's that different buttons actually have different hyperlinks. So let's see an example real quick, because you'll be doing it yourself and we're not telling you how to do it. There's some links on the tutorial this week that explain, but you could take an image and you could edit a hyperlink or create a hyperlink, and it tells it which slide to go to. I don't know if you can name your slides in PowerPoint, but you can see a preview. This can get unwieldy, but I doubt many of you will have that many slides that this will be that hard to work with. But you could see that you could make this same prototype in a website as well. And in fact, the final thing that I made for this client was a website. But that took, 100 hours as opposed to this person probably spending probably 20 hours making this PowerPoint. So let's just really quickly see that we can navigate in it. We're not expecting you to make it so that text fields work because that's not a thing in PowerPoint. It's not really relevant. And what this was showing actually is that when we first log into the app the very first time, they will see the settings page. You can see that the person who made this for me had some annotations here. You can do this if you like to help with representing your ideas. I provided this as an example, but it's by no means a perfect guide of how you should do things in PowerPoint. So don't think just because they've used exactly this styling or something, you have to copy it. In fact, they've probably made some mistakes or things that make it harder to use this that you might not want to emulate in your prototype. For example, if I accidentally click somewhere else, it'll just take me to wherever the next slide is. So it's still possible to do a linear traversal through this. I think you can turn off that feature in PowerPoint. If someone works out how to do that, let everyone else know. But in general, if I wanted to click on a functionality, I've only enabled exercise and weight. The other ones don't work because I just deleted the slides. But this takes me to the exercise part. It's showing me that the first time that I get here, it'll give me this warning, and I can navigate some of these. It's showing me that there's a graph. The back button works, although an example of them not doing this perfectly because they weren't trying to make an assignment here. When I press back, it's showing me this warning again. Why they chose to make it go back to this screen and not the next screen, I don't know. So they didn't spend a whole lot of time on this, but it's a good example. Close button works, goes back to the menu. You can see that we can prototype and get a fair idea of what this product is supposed to look like here. I know it's 2:48, but I am just going to quickly open up some slides that it's only pictures, trust me. And the reason I'm doing it is that next week I'm not here. You'll have Meredith as your lecturer next week because I'm in America, and so she won't be able to explain what's going on this particular slide I'm about to show you. I'm not going to show you 20 slides. I'm going to show you like 2. We can see that I'm literally stealing this from the other unit that I taught as an example of prototyping. Mobile students can tune out here, they've seen this before. With Party Golf, trying to come up with the idea and pitch it to the other team members in this case was done on a whiteboard. So you can see the wonderful Ian here, he had this idea in his head before we went and made this game, and in order to get us on board and have an idea of what the idea was, so to communicate it and make sure that we liked it and had the same terminology, he drew it all on a piece of paper. That's great. And then for us to communicate the game idea to people 48 hours later at a party, we made a very crummy prototype where people could play the game and change settings. And then once that was trying to communicate the idea to our friends. Then in this version up here, it's an early version of the game that was on a platform called the Oya, where we're trying to communicate to potential buyers, this is what our game looks like. It's not final, but later on it's going to look prettier and fun. But this was fun enough and interesting enough that we got people playing it, and then we had our final product. Very last set of slides was that we prototyped menus. I'll leave this for you to look at in your own time. I might show them when I get back from America. But you can see that our menu went under quite a few iterations. Actually, to the point that for Party Crashers we have a brand new menu. So this wasn't here in the slides in first semester. We have another layout, another iteration here. So that's an example of prototyping. Not a great example because from the very start this was an extremely complicated set of code, and then we went back to drawing on paper. So don't do what we did. Draw on paper first, then write some fancy code. That's it from me. See you all. You guys will see Meredith next week. I will see you all when I get back from America. Yeah. Oh, that's true. I'm not allowed to be late or run over time because I've got another class this time. See, yep.